Hi class, this is Dr. Karsten, and today I wanted to go over electricity and circuits. You've already watched the Generation Genius video, so I don't want to go over all of that information. I just want to do a little bit of review about the material that you learned. So, we have been working on understanding electrical circuits. And I want to remind you that an electrical circuit is a path that can allow electricity to flow when it is closed. And that's really important. So we're going to kind of look at this really quickly. Here I have an electrical circuit. I have a battery, which is my energy source. I have my wires that conduct the electricity. I have my resistor, which is the bulb. And I don't have a switch, so I'm going to just use these as my switch. So electricity generally flows from the positive side of something to the negative side. The electrons are going from positive, they go through it, and they end up on the negative side. We usually like to use the red for positive and the black for negative, but it would work either way. So I'm going to attach this to this side, and then I'm going to go ahead and attach this to this end, and you can see that the light bulb lights up. So this is a closed circuit. Open, closed, open, closed. Think of it as being a closed circle. Circles are closed, and the electricity would flow all the way around. So one of the things that they did was they tested to see if things were insulators or if they were conductors. Remember that insulators are not going to allow electricity to go through, whereas conductors will. It's kind of like a conductor on a train, and that a train brings people from one place to another. Conductors bring electrons from one place to another. So I have the wood attached this time. I'm going to connect this side, and the light bulb does not light up. That's because wood is a great insulator. It does not let electricity flow through. But we can also try a paper clip, which I have misplaced. Let me hit pause. So I found my paper clip. I had put it away already. So I'm going to attach it to the circuit. And let's see if we can make a closed circuit. And we can. The paper clip is a good conductor. Now, I don't know if you remember from the video, but they showed us that for the most part, metals are the things that are going to be conductors, and they're notorious or known for being good conductors, and that other items were not, except for the graphite in the pencil. And that's really interesting. Graphite is actually on the periodic table the only non-metal conductor, which I think is super cool. All right, so again, you have to have an energy source, you have to have your wires, you need a resistor if you want to see what's going on, if you want to see the electricity flowing through, and you can use a switch as well. We don't have one here. So I want to now talk a little bit about parallel and series circuits, because that was another thing they discussed. So let me just kind of move some of this stuff out of the way so we can talk about this. So remember how we learned about parallel lines, that it's two lines that are next to each other and they never touch, they never cross. Well, when we're talking about series and parallel circuits, we're going to be thinking about the same sort of thing. So remember that when you have a circuit, you're going to have your battery, right? And I'm just going to put for now the word battery for us. And then you have your wires, and you had your resistor, which was our lovely light bulb, and it would light up when we had a closed circuit. When we have it like this, I want to show you one more thing with the light bulb. When we have it like this, though, the light bulb is actually helping us to complete the circuit. If I were to pop this light bulb out, which I can do, I want to show you what happens. This is important for you to know. Now, it's not, well, you can't see it, but it's not actually a closed circuit. Go ahead and do this. Oh my goodness. Alright, I probably should pause because I don't think I'm going to be able to do this without, you know what the problem is? It's because this is broken. But anyway, when you take this out, you have actually opened the circuit. And that's because if you see here, I don't know if you can see this very well, but the metal isn't actually touching each other. They're separated by the plastic, which is an insulator. So if I had another light bulb here, and I took this one out, it would actually open the circuit and it wouldn't work. When I screw this light bulb back in, if I can do a good job doing this, they're kind of a pain to put in sometimes. What it does is it actually touches right here, this metal, and it closes the circuit for us. All right, so back to this. So right here, I have a plain old circuit. I could actually go ahead and put another light in here. And that would be parallel circuits. Because you can see, just like two parallel lines, these are not on the same circuit. They're on different circuits. They're just utilizing the same energy source. Or you could do a series circuit where you would have a light bulb like right here, and then you could put maybe another light bulb right here, and then you could put another light bulb right here. And the thing with this kind of a circuit is that if I were to unscrew one of these light bulbs, all the light bulbs would go out. All right, so I want to show you some really cool drawings here that I wanted to look at with you. So these are some examples of problems with circuits. So let's look at this one. So you know what, let me move this down a little closer for you so you can get a better view of this. All right, so what's wrong with that circuit right there? Can you see what's missing? What I notice is that the circuit does not have a wire that returns the current to the battery's terminal right here. This is the positive side. In order to make this work, you would have to add a wire going from here to here, and that would close the circuit. So this is an open circuit. It's not going to work. So why would this light bulb not light up? Well, because the switch is open, which means it's an open circuit. You have to close the switch to close the circuit so that there's a closed path for the electrons to flow. What's wrong with this one? Well, the problem with this one is that both wires are going to one side of the light bulb. And so the electricity is not going to flow through the light bulb and the socket. One of the wires would need to be connected to the other side of the socket. So that's the problem with this one. That's why this one wouldn't light. All right, so let's take a look at another page. So here, we have to decide, would the light bulbs light up or would they not light up? Well, let's take a look at this one. Do you see a problem? I do. Remember what I said to you. If you unscrew the light bulb, then the circuit is open. Remember that the light bulb is actually part of the circuit. It's completing the circuit. So for this one, this would not light up. What about here? Do you see any problems here? I see it looks like they were maybe trying to do a series circuit, but the problem is that there's no connection here. You'd have to connect these two to complete the circuit to make it a closed circuit. So this would not light up. What about this? Well, this looks pretty good. Look, we have the electricity. It's flowing through the batteries. It's going to go through the light bulb and back to the batteries. So it's going to go in a circle. So this will light up. What about this one over here? Do you see any problems? Try and look at the circuit. Do you see a problem over here maybe? What I see is that all the wires are connected to one end of the battery. That's not going to help. We need it to flow all the way around. So this is not going to work. These would not light up. What about this? Would these light up? Let's take a look. Positive to light to battery, negative. That would light up. So that would work just fine. This, by the way, is a series circuit. What about this? Let's look at what's going on. You know, I think this is kind of confusing. So what I'm going to do is I'm going to trace this light in orange so that you can see where this one's going. And then I can go ahead and I can trace this light in blue. And what I can see is that there are two separate circuits running. I have an orange one and I have the blue one. So this is actually parallel. I know they don't look great in parallel, but you have two separate circuits running. They just happen to be on the same battery. So these would both light up because they are both connected correctly to the battery. All right, my friends, I think that is it for tonight. I hope that you enjoyed this little demonstration and going over some of this, and I will see you in our classroom. Bye.